And welcome back, everyone. Let's get started again with some application questions. And I know area requires us to concentrate a lot, but we're almost there. An arts and culture teacher at Little Tots Primary School wants to decorate part of the playground by painting a triangle, a circle, a rectangle, and a square onto a tiled area on their playground. She intends playing a game with the learners where she calls, let's just put an S in there, calls out a shape, and the learners have to go to the decorated shape on the playground. All right. The triangle is 6 tiles long and 3 tiles high. The circle has a diameter of 4 tiles. The rectangle is 4 tiles long and 2 tiles high. The square is 2 tiles high. And then they tell us, most importantly, that each tile on the ground is a square with the length of 15 centimeters. So if I look at this, I'm just going to take a measurement in the middle somewhere so we can see it clearly. That line would measure 15. That line would measure 15. That would measure 15. And that would measure 15. So all of those squares measure 15, which tell us that the measurements we're dealing with is how long each of these squares are. Let's see how that works. All right, in this case, the first question, calculate the area of the triangle. So if you remember, the formula to find the area of a triangle is half times base times height. In this case, it says the triangle is 6 tiles long and 3 tiles high. So what have they given me? They've given me the base of 6 tiles long and the height, which is 3 tiles long. Ah, nice. So let's bring that all together. Remember, each tile measures 15 centimeters. So if I break it up as follows, if I say the base is 6 times 15, and I get that to be 90 centimeters. I know the height is 3 tiles long, so 3 times 15. And that gave me 45 centimeters high. Now we can find the area. All right. Area for triangle, half times base times the height. All right. Let's put everything into the formula, use a calculator, get our answer. So that's 90, that's 45. And my answer is 2,025 centimeters squared. Nice work. One down. Let's keep going. All right, what's next? Calculate the area of the rectangle. So if I find the rectangle, there it is. The rectangle is 4 tiles long and 2 tiles high. So in this situation, when they're saying high, it's not talking in terms of standing up, right? They're talking in terms of it laying across the floor. So if I think about it, the 4 tiles long will be the length, and the 2 tiles high would be the breadth. And that should be the measurements we need for the formula. So for a formula for an area of a rectangle is length times breadth. And I've got these. I've got the length, which is 4 tiles long, multiplied again by the 15. There it is, in case we forgot where it was. All right, because remember, each tile measures 15. Right, so 4 times 15 will be 60. That again is in centimeters. Breadth, okay, that is 2 tiles long. 2 times 15, I get that to be 30 centimeters. I've got the length, I've got the breadth. Let's use the formula. Therefore, area is length times breadth. All right, 60 times 30 gives me 180 cm squared. Centimeter squared. Nice work. Let's move along. All right, the next question. Nazia, a prospective chef, is trying out a new savory called half moons. To make the savory, she must use pastry, roll it out into circles, which will be folded into half moons. The circles are all equal in size. The diagram shows the rolled out pastry in the shape of a square with some circles. So, looking at the dimensions, if that is 30 that side, then we know that from that point all the way down to this point, that's also 30 centimeters. That's important information. The area of the rolled out pastry is 1,440 centimeters squared. All right. Determine the diameter of one of the circles. Okay, so just get rid of this. Don't need that for this question. If I look at the top part, that measures 30 from one point to the other point. And then notice what's happening with the circles. They are all touching. Can you see that? So if I run a line that way, all right, what do you notice? That line and this line are the same length. Do you see that? So what I can do is I can count 1, let's get rid of that quickly, 1, 2, 3, 4, 5 circles. So if I said the line is 30 and each circle measures 5, 30 divided by 5 gives me 6 centimeters. There we go. Nice. Let's do another one. So, excuse me, determine how many circles can be cut out of the rolled pastry. So what I think we need to do here is we need to find the area of one circle. So the area of a circle, we first need the radius. Let's get some space there. Radius is the diameter divided by 2. Because remember, with the previous question, we've already worked out the diameter. The diameter was 6. 6 divided by 2, here I get 3 centimeters. Nice. So, once we have the radius, we move on to the second part. We use the formula. And we realize we're dealing with full circles. So we'll use the full formula. Area is pi r squared. No reason to divide it by anything. So pi 3,142 times 3 squared. And here I get 28,278 centimeters squared. All right, so what does that tell me? That tells me that one of these circles, all right, just one of them, measures 28,278. I need to find out the amount of circles I can cut out of this particular pastry. So what I need now is the area of a pastry. Remember, they said it was a square and stuff like that. But from before, if you think back, they gave us the area that she rolled out already. So there's no reason to calculate it. Just to remind you guys, the area of the pastry is 1,440 centimeters squared. So I don't need to calculate it here. I'm just going to use that value, 1,440. That's the total area of the whole pastry. And I'm going to divide that by 28,278 to figure out how many of these circles we actually can get. It's 50,922,978. All right, on the calculator. Now, looking at this, we've got to do a bit of those maths-lit rounding off now. If I round it up and say it's 51, that's mathematically correct because the 9 would round the 1 up. However, if we did that, we'd be wrong because we're then saying you can actually cut out 51 of these, but you can't. You've got to round down in this situation. Remember that. Maths-lit rounding. So this is approximately equal to. So we can't do this one. Let me just get that arrow away from there. We can't do that. No. This is actually 50 circles. Take care. Nice. We've got this. Well done. Let's carry on. So the next question now, it reads, the remainder of the pastry, the wasted pastry, cannot be rolled out as the pastry is going to lose its puffiness. All right. Calculate the area of the wasted pastry. Remember, the area of the rolled out pastry, here's another reminder, 1,440 centimeters squared. Okay, so let's analyze this. Let's see what's going on. We've cut out all of these circles. That's one, and that's one, and that's one, and that's one, and all of the others that need to be cut out. Do you realize that the circles will then leave a little bit of pastry in between all of those gaps left once we cut it out? So they want to know what is the area of that little pastry pieces that have been left out. So what do we need to do? We need to see what is the total area of all of these circles that have been cut out? Once I find those, I can take it away from the total area, and the answer should just be the remainder. Because this 1440, that's all the pastry we have. But we're cutting out just the circles, and that's why that should work. Let's give it a go. So to start off with, the area of all the squares would be 50 squares multiplied by 28,278. If you remember this 22,278, it's the answer from the previous question where we worked out the area of one circle. And I get 1413,9 centimeters squared. Then, all right, let's see what's wasted. If everything is 1440 and we take away, we cut out 1413,9, what are we left with? 26,1 centimeters squared. Nice work. Ended off on a high there. Let's take another short break. I think we all deserve one. And when we get back, I'll wrap things up. See you soon.